Hi, so in this video we will gonna tackle regarding the volumes of solids of revolution. So last time we have compute the area of some plane using the definite integral. So we can also extend the concept of the definite integral as the limit of an infinite sum in computing volume. So it is also the another application of our integral. So we have the area and the volume, and uh, other physical problems can also be computed using the integration such as the moment, the centroid, and what else, the moment of inertia, and so many more. That's why uh, it makes the integral an indispensable mathematical tool, especially in engineering and um, and allied in allied fields. So in this video we're gonna tackle only the volumes of solids of revolutions. Okay, so we have three methods where we can use in order for us to solve the volume of solids using the integral. So the first method is the what we call the circular disk method. Circular disk method. Second one is the circular ring method, and the last method is called the cylindrical shell method. Okay, so we will gonna try to compute the volume using these three said method and apply the integration. Okay, so but before that, let us first have the definition of the what we call the solids of revolution. The solids of revolution. Solids of revolution. Okay, so by definition, the solid of revolution is a solid formed by revolving a given plane about an indicated axis of revolution. Axis of revolution. Okay, so once again, the solids of revolution is a solid formed by revolving a given plane region about an indicated axis of revolution. So to further illustrate this, say let's have our axis. Say we have the x, y, and our z axis. Then let's have our say this is our plane region R. Plane region R. And it says here the solids of revolution is a solid formed by revolving a given plane. So say let us consider the xy plane, this plane, the xy plane, the xy plane about an indicated axis of rotation, and let's consider our x as our axis of rotation. So if we rotate this plane region, if we rotate our plane region R in the indicated axis of revolution, which in this case our x-axis, then it can form a solid volume. See if this is so. If we rotate this, then if we rotate this plane region, then it will looks like this, right? And this is what we called the solid of revolution. Yan. Once again, the solids of revolution is a solid formed by revolving a given plane region. Say this is our given plane region about an indicated axis of revolution. Say this is our axis of revolution about x. And if we rotate this plane solid, I mean this plane region about this axis, then we can have a form called the solid, this part here. Okay, by considering only the x and y plane. Okay, so another illustration, say this is our x and y plane, this plane. Say this is our x and y plane, and say we have a plane region R, and then if we rotate this using our axis of revolution x axis as the axis of revolution, then our solid of revolution here might looks like this. So we have, say looks like this, right? And but if we will consider our y as our axis of revolution, then we need to rotate this on axis y. So instead of having this form, we will have and right. So it will looks like this one. Okay, So once again, the concept of the definite integral can be adopted to compute the volume of solids of revolution. Okay, so we have three methods, what we call the circular disk method, a circular ring method, and cylindrical shell method. We're in the definition of our solids of revolution is a solid formed by revolving a given plane region. Say this is our given plane region about an indicated axis of revolution. So we need to determine first our plane region in its axis of rotation before we can come up with the solid of revolution, or the solid form after rotating this plane region about its axis of rotation. So say we have this right triangle here rotated at x-axis, then we will form a solid that looks like this. So the same goes with the what shape is this? A rectangular shape, for example, about the x and y plane, and then if we take as our x-axis as the axis of revolution, and then if we rotate this plane region here about x, then we will come up to solid that looks like this. But if we will consider our y as the axis of revolution, then our solid will looks like this. Okay, so it is very important the the uh, plane region, and then also it is very important which axis are we going to rotate this plane region to come up with the solids. Okay, so on our next video we will gonna tackle the these three methods: the circular disc, the circular ring, and the cylindrical shell method, on how to compute these said solids, the volume of the said solids. Okay, so see you on our next video.